QG21-W test kit allows you to quantify the total active biomass and stress level anywhere in your industrial or municipal wastewater treatment plant. This includes influent streams, activated sludge, anaerobic bioreactors, UASB reactors, and membrane bioreactors. One of the most important steps for any microbiological test is sampling. Be sure to be consistent and take into consideration the application. Collect the recommended sample volume in a clean and contamination-free sample bottle. Ideally, the sample should be tested immediately after sampling for best results, or within 2 hours of collection. The first step is to rehydrate your freeze-dried luminase enzyme. This involves removing the rubber stopper from the amber luminase vial, opening the clear vial of buffer, and pouring it into the amber vial. Let it sit for 5 minutes to completely dissolve, and when the liquid is clear, you're ready to start. If your luminase is already rehydrated, let it come to room temperature before beginning. The luminase enzyme will degrade over time and with exposure to heat and direct sunlight, so the calibration step should be done at least once per day or before each set of samples. This allows you to standardize the enzyme's activity against a known concentration of ATP. To run the standard, hold the UltraCheck bottle vertical and add 2 drops, 100 microliters, of UltraCheck to a new test tube. This is known as the assay tube. Using the red micropipette and a new pipette tip, add 300 microliters of luminase to the assay tube. Your results should be at least 500 RLU. If it's below 500, the enzyme is no longer active and the bottle should be discarded. Rehydrate a new vial if this occurs. To test for total ATP, using a wide-mouth pipette tip, transfer 1 milliliter of sample into a new 2 milliliter Ultralice 3021 extraction tube. Allow it to sit for at least 1 minute. This will lyse all living cells and extract the ATP. Next is the dilution step. Open an 8 milliliter Ultralute resin tube and pour in the contents of the Ultralice 3021 tube. Transfer the solution between the 2 tubes several times to mix well. This will help remove any potential interferences. Cap and invert the dilution tube several times and allow the beads to settle. The ATP is now extracted and you're ready to run the assay for total ATP. Using a new pipette tip, transfer 100 microliters of the dilution tube to a new assay tube. Be careful not to aspire any resin beads. With a new blue pipette tip, add 300 microliters of luminase to the assay tube. Mix for 5 seconds and take the reading in the luminometer within 5 to 15 seconds. Next, we will test for dissolved ATP. Mix the sample well and transfer 100 microliters of sample into the 10 milliliter LumiSolve tube. This is stabilizing only dissolved ATP from dead and stressed cells. Allow the solution to sit for at least 1 minute. Transfer 100 microliters of the LumiSolve solution to a new assay tube and add another 300 microliters of luminase. Mix for 5 seconds and take the reading in the luminometer within 5 to 15 seconds. The luminometer records the result in relative light units, RLU, and through a simple calculation done automatically in the software, the result is converted to nanograms of ATP per milliliter. The amount of cellular ATP from living and active cells will help you optimize the overall health of your wastewater system. The Biomass Stress Index, BSI, provides a measure of acute toxicity. Refer to the data interpretation guidelines in your test kit instructions for good control and high-risk ranges. Because every wastewater treatment process is different, Baselines for each system should be obtained for 1 to 2 weeks before using ATP to make process control decisions.